Hey everyone, welcome back. This is a video for Econ 180, economics, urban economics, and today I'm going to be talking about one of the problems that is on our homework 4, looking at housing policies, looking at home ownership, and looking at housing demand. And so the first problem some people had some questions on was just looking at the hedonic price model. And for that problem, you just want to go through and use what elements you have, drop anything that there's not a value for, and estimate the price of the house. The next problem was the textbook problem. And so that's going to be in Bruckner's Lectures in Economics, and it's problem 7.1. And it's a little bit of it's basically a mathematical stock and flow model problem. And so I'm going to go through the elements of it, and then what I want to do is talk about the second half of it. I only ask you to do parts A through E, but the second half of it basically looks at how rent control would alter the model, alter the outcome, and then asks you to graph it. And I think that's fun. And so I'm going to talk about it a little bit too, because the homework part that I asked you to do is pretty straightforward. And so I think it'll be nice to add a little bit of depth to it. So let's get started. So we start out with some general information. The problem says that we're going to be looking at the stock and flow model of housing, talking about the time associated with adjustment, and the effects of rent control. And so we are given a demand curve that is, there it goes, a demand curve given by P equals 3 minus H, where H is the quantity of housing available. Excuse me. So that's our demand curve. And then we're given a supply curve. And remember, in the stock and flow model, the supply is a function of price, and so changes in the price signal a change in the supply of housing. And so our supply is given by P equal to change in housing minus plus 2. So that's our supply function from the problem, right? So the very first part says, hey, calculate the equilibrium price. Remember, the equilibrium price of the stock and flow model is going to be the price at which there is no incentive to build new housing. So let me grab a couple of pens real quick and remind you what the stock and flow model looks like, and hopefully that helps. If I don't get all my colors, it's not fun. So, remember, the stock and flow model of housing is cool because it allows for the reality that in the short run, the supply of housing is inelastic at some level H, and there's some demand and some equilibrium price. But just because supply is inelastic in the short run doesn't mean it's inelastic in the long run, right? We do get more housing over time, and that's where the flow component comes from, and that's this supply curve that is upward sloping for the change in housing. Right, that's my little tiny delta H. I'm going to need a smaller pen to write that out. There we go. Delta H. And so if prices are high, it sends a signal to increase housing. If prices are low, it sends a signal to demolish or stop building housing. And that's what we're doing. And so we have a formula for our downward sloping demand curve with a slope of -1, and a formula for our upward sloping change in housing supply curve with a slope of +1. And so what we want to do first is find that equilibrium price. And the equilibrium price is just going to be the price at which there is no incentive to build or demolish, right? That price for equilibrium housing where the change in supply is 0. So to do that, to determine the equilibrium price, we just set change in housing to 0. And it's super easy to solve for the equilibrium price, right? It's super easy. 0 plus 2 is 2. So the equilibrium price is 2. Cool? So far, so good. So that's part A. Part B says, if we assume that the current level of housing, the inelastic supply of housing, is equal to 1, does that equilibrium price persist? Like, is our model in true equilibrium? And we can test that really easily. We can just come over here and say, okay, let's take that demand curve and let's put P equal to 3 minus H equal to 1. 3 minus 1 equals 2. P equals 2 equals, yeah, that equilibrium price. So we are, there we go. So yeah, we are in equilibrium. Straightforward, right? Super simple. So what we're saying there, and I'm going to draw this for y'all, is that we have our model in equilibrium at this point where price is equal to $2. And there's our demand, and our supply of housing is equal to 1. I know that's tiny, but you can kind of get what I'm saying, right? So we're just imposing values. So we're in equilibrium. There's no incentive to build or not. Price is $2. Quantity of housing is 1. Now, of course, we want to impose a demand shock. So that demand shock is going to change our demand curve. So now we have a new demand curve of P equals 8 minus H. So initially we had our equilibrium price of 2 and our equilibrium value of housing, which was 1, and our supply curve was P equals change in housing plus 2. And now we have the demand shock. And that's going to be that P equals 8 minus H, where before our demand was P equals 3 minus H. So, given this demand shock, we want to see what the new price is going to be, right? There's a shock to demand. Demand has gone up. We still have that initial level of housing, H1. So what is the new price? Let's say P bar going to be. That pen's too stumpy to be functional. So let's try this pen. So I'm going to put it into our equation. We have P equals 8 minus H. H is currently set to 1. So the new price, I'm going to call it this P hyphen, is 7. An increase in demand, while supply is inelastic and cannot respond, is going to drive prices up dramatically. So now the new price of housing is 7. So that's part C. Part D says, now we want to find the change in H, right? Find how much we're going to see housing supply change. Given that price signal, that's going to translate from the flow part into the stock part. How much are we going to see the supply of housing increase? So we plug that into our housing supply formula. So we've got the new P is 7 equal to change in H plus 2. So I'll subtract 2 from both sides, and I get that the new change in H is going to be 5. So basically, with the demand shock, the price of housing goes up to 7. In order to return us to equilibrium, we need to increase housing by 5. Buildings, units, 5,000 apartments, who knows, right? We're just using these numbers as placeholders as a way to go through the process of checking how this model works in like a real dynamic way. That's better. Okay, so that's part D. So now we've got this change in housing, and the other cool thing we can do, if I find another pen, is we can find out what the new H store of housing is. And it's going to be what housing used to be in equilibrium plus that change in H, which means it's going to be 1 plus 5 or 6 units of housing. Does that make sense? Hopefully. So let's graph it out. Let's see what that would look like. So I'm going to go through and clear this out. I need to get another dry eraser. And so I want to set up the stock and flow model of housing. Where there's some supply of, I'm going to move this over. Make it realistic, try and put it to scale. So there's my supply of housing where H is equal to 1 and some level of, I'm going to try that, fix that too. Here we go. You'll see what I'm doing. Just trying to give myself room to make the moves that I know this model is going to make. The equilibrium price of housing is 2, and that translates over here to the flow part of the model, where we have the upward sloping supply of changes in housing that can be positive or negative. Then we have the demand shock, which shifts demand way up. Didn't label my demand curve. Now I have a new demand curve that elicits a new price, which was that new 8 price, right? Oh, sorry, no, 7. And sends this signal over here to increase housing. So change in housing was going to be equal to 5. Does that make sense? The demand raises prices, which sends the signal to have a positive change in housing, which then comes over here to the market where we see the supply of housing shift out. Give me 1 second. Oops. Okay. So I shift the supply of housing out. And now there's this new supply where the supply of housing is now 1 plus 5 or 6. Now this shows that I went back to the equilibrium price, and that's what our model assumes, is we return to that equilibrium price. I want to prove that mathematically, and so I'm going to go back in and use those same equations to prove it. So to do that, what I'm going to say is put the new value of H into the new demand curve. So remember we had that new demand curve that said P is equal to 8 minus H. And before we had that high price of 7 with an H of 1. Now we're going to have 8 minus 6, which gets us back to our equilibrium price of 2. So now we're back here, and there's no new incentive to build. So the model works the way we expect. Awesome, right? So that's it. That's the homework assignment, right? There is more to it. The next step would ask you to set a rent control price, and I'll just kind of show you what that would look like because it's fun. Because who doesn't want to talk more about how much economists hate rent control? So if we imposed a rent control price, that's the next step would be F. The next step would be to say, what if rent control was imposed at price C equal to 3? So now we have a rent control price equal to 3, and that's going to be this over here. What would that do? Well, what we do is then we insert that price into this change in housing supply formula and see what we pull out. What we end up getting is, if you insert that price of 3 equal to change in housing plus 2, you get 2 minus, subtract 2 from both sides, you get a change in housing of 1. We know that the market equilibrium, when the market was allowed to function normally, the price signal was a change in housing of 5, but here it's just change in housing equal to 1. And so what that means is every period we'll get 1 more unit of housing until we get up to equilibrium, but basically it's going to take 5 times as long to get there, because instead of just going from 1 to 6 in one iteration, in one period, we're going to go from 1 to 2, and then from 2 to 3, and then from 3 to 4, and then from 4 to 5, and then from 5 to 6, and then we'll eventually get to that equilibrium. And that's the way this model works. And so that's one of the useful things it tells us about how housing works, is it tells us how important that price is as a signal to developers that there is pent-up, unmet demand, and it needs to be, we need a change in supply to solve it. So that's what's really cool about that problem. So if you go through and you look at the rest of it, Part F says to look at how the rent control would affect the stock of housing, how long does it take to get to the price back in equilibrium, and then asks you to illustrate it with a graph like that, which I think is also a really good exercise, because that's kind of the fun, cool thing about economics, right? We demonstrate these ideas graphically, mathematically, and in writing, so we communicate those ideas in a bunch of different ways. So that's cool. Let me know what questions you have. Hopefully this helps you with the homework problem. I don't think it was too hard in terms of what some of these other problems we've had so far, but I do think it was fun. And I'll see you next time. Okay, thanks so much.